Good day, everyone. I'm here to talk about a new Eclipse Foundation project focused on reducing the fragmentation in the consumer and IoT product industry. Our ultimate goal is to raise the bar for creating great IoT products. Before we begin, a little bit about myself. My name is Amit Kucheria, and here's a picture of me. Oh, I need to fix that. How about that? Hi there. I am the Chief Product Architect for Oniro. I am also a Linux and Zephyr developer, and over the years I've worked on multiple products, distributions, with OS vendors and SoC vendors. Let's begin with the problem statement, the Internet of Things. There are hundreds of companies across the world, small and big, building thousands of devices that fall into the broad category of Internet of Things. These devices or products run a variety of open source operating systems like Linux or an RTOS such as Zephyr, FreeRTOS, etc. But they suffer from some common problems. Internet of Things can also be called Internet of Abandonware because in a lot of cases the companies no longer support the product after releasing it to the market with software updates or bug fixes. These devices very often suffer from silos due to their dependence on cloud connectivity for the most basic day-to-day functions, as well as the inability to be mix and matched with similar devices from other vendors in the local network. Very often, these devices lack the most basic security features such as a trusted boot chain, encrypted network communications, encrypted local storage. They may also have unused network services running all the time, thereby exposing the device to network-based attacks. They may also suffer from a terrible onboarding experience, sometimes requiring you to download an application from the App Store just to configure the most basic of functionality. So you end up with an application for every product or device that you have in your home. Surely we can do better than that. Let's consider the path to building a product using open source software. You need to start with a shopping list. You start with your hardware. So you have to decide whether this is something that will run on a microcontroller or a CPU. If it's a microcontroller, you would go for some real-time operating system like Zephyr, FreeRTOS, etc. If it is running on a CPU, you would probably go with something based on Linux. Now, depending on your use case, you'll have to put together the list of software components that are required to satisfy that use case. So for example, if you're building a smart speaker, you obviously need to put together a list of components required to record and play back audio. So far so good. Now you need to integrate all of these software components into an image build that when flashed onto your target hardware device will produce the behavior that you want from the product. In order to integrate all of this software in a deterministic, repeatable manner, you might choose to use a project such as Yocto or Buildroot, which act as repositories of recipes for tens of thousands of different software components. So what they make it very easy to do is to pick a bunch of software components and build them into an image that you can use. They're also very flexible in that they allow you to tweak the configuration of these components. But this flexibility comes at a price. Very often, the recipes will not build the software with the exact options or features that you want for your product. So you end up having to customize this. So now you have a bunch of recipes and you need to comb through them and tweak them to build the various software components just right for your product needs. This is actually a lot of effort. So now let us look at where some of the engineering effort into building a product goes. The effort required in building a product software stack can roughly be categorized into four parts. So the first part is where you build the core software stack on top of which you will develop your application. So this includes the kernel, the tool chain, the various low-level libraries, the application frameworks that you might use to build your applications on. Once the core software components are chosen, the engineering team typically shifts their focus onto setting up processes to enable rapid development. So they set up CI/CD infrastructure, testing infrastructure, write documentation, and set up maintenance processes. This effectively allows them to catch regressions very quickly during the development process. And if the engineering team really cares about the quality of software they put out, they probably even have security policies. For example, the root of trust, starting at the factory floor, signed images, key rotation policies, providing over-the-air updates for software, and even an IP compliance policy. Another thing the engineering team ends up spending time on is configuration for their products. This could be, for example, if you have multiple variants or SKUs of a product and each of them have a different configuration that needs to be maintained separately. It could be related to your product specific policies, so that you disable default user names and passwords, prompt the user for a stronger unique password, prompt them to set up secure SSH, maybe disable unnecessary services so as to reduce the number of ports that are open to the network. All of this kind of policy and configuration needs to be saved separate from the core software because this could be very specific to your product. And finally, you have your application. In a lot of cases, your own application code and business logic could be as little as 5 or 10% of the overall code that is shipped onto a product in terms of lines of code as well as effort. Many of the areas such as OTA, security, and IP compliance require experts that might not be available to all companies. It is also work that is being repeated across the hundreds of companies building IoT devices, when you could actually share some of this work and focus on your own applications. This is what we are proposing with Oniro. I invite you to join the Eclipse Oniro project to help build an open source, hardened IoT software stack. By using shared engineering, we would like to raise the bar for IoT software security. By using opinionated defaults, we would like to deliver key features such as over-the-air updates, SBOM generation, and hardened network defaults out of the box for every user of Oniro. This in turn will allow engineering teams to spend more time on their applications and their value additions instead of the same thing being repeated across many companies. And we would like to offer these features for devices running CPUs as well as microcontrollers.